In this video, we're going to look at problems that are similar to problems you will see on the checkpoint. So let's look at the first one, determine whether the relation is a function. My favorite way to do this is to look at the graph. There's other ways to do this as well, but I think the graph, you can really get a picture of what's happening here and decide whether or not it is a function. So if you're using your graphing calculator, then you know that when you graph, you have to solve for y. So let's go ahead and do that. So y squared plus 4 equals x. So we got to move the 4. So let's subtract 4 from both sides. That's going to leave me with y squared equals x minus 4. And to get y by itself, I would have to take the square root of both sides, which is going to give me a plus and a minus. Because remember, when you take the square root, there's 2 roots. When you graph this in your graphing calculator, you would have to enter in 2 separate functions. You would have, because this is actually the positive x minus 4, and you would have to enter in the negative of x minus 4. And this would be the whole function together. So you would have to graph them in 2 separate things, which the fact that I'm graphing them in 2 separate equations already tells you that this is not going to be a function. So we can, we already know that going in, but let's go ahead and look at the graph just to confirm. So I'm going to go to my online calculator. Okay, so here is what the graph looks like as a graph, and you can see that it's a sideways parabola. So if we take that idea and we use the vertical line test, would this graph pass the vertical line test? And the answer to that is no, it would not pass the vertical line test, because if we draw a vertical line through there, and I'll just sketch the graph so you can see, here's what the graph would look like. We can draw a vertical line anywhere through there, and look, we're going to hit the graph in 2 spots, which tells us this is not a function. So no, not a function. In this next problem, it's also talking about the vertical line test. So with the vertical line test, remember, you can only touch the graph in 1 spot. So far, all of my vertical lines are only touching the graph in a single spot. So it looks like that this one is actually, yes, this is a function. Because it passes the vertical line test, it only touches, when I draw a vertical line, it only touches the graph 1 time. Okay, so now let's go to the third one where it says graph the function. So let's go to the toolkit where we can see the basic shapes of all of our graphs. We're dealing with x squared minus 3, so we really need to know, what does x squared look like? So here we are with all of our information in our help Padlet. When I click on our toolkit, I can see over in kind of in the middle, we have f of x equals x squared, and we've got the shape of a u. And that's going to be our main function that we're dealing with. So we're dealing with a u-shaped function, and whether we're adding something or subtracting something, it's still going to maintain that shape. It's just going to move it around our coordinate plane. So now that we have an idea of what that looks like, let's go back and look at our function. Our function is f of x equals x squared minus 3. So we've got that basic function of a u-shape that's vertexes at 0, 0, and then we're going to subtract 3 from it. So it's going to maintain that shape, but where is it going to go? So what does that minus 3 do? And if you've worked with a lot of transformations, you already know what's going to happen. If not, put it in your graphing calculator and you'll be able to see what happens. So here I am in my online graphing calculator, and you can do this on your graphing calculator. But so far I've put in y equals x squared, and here's what we confirmed with our toolkit. We know that x squared are U-shaped graphs. Now I've just got x squared, but look what happens when I do minus 3. It shifted it down 3 units. So that would be our graph. It's still symmetrical about the y-axis. It didn't shift right or left. That minus 3 only shifted it down 3 units. In this problem, we're given a graph, and it says use the figure below to approximate the value. Now remember that when we have to find out what f of negative 2 is, negative 2 is our input, or our x coordinate. So we have to find the output, or the y coordinate, that goes with it. So that's what we're looking for. So we're going to look at our graph, and we need to go to our graph where x equals negative 2. So on my x-axis, I have negative 2, and I have to go to that spot on the graph, which would be right here. Okay, x is negative 2. And there is my graph at negative 2. So what's the corresponding y value that goes with that? Well, it looks like positive 2. Now, here's a problem. It's asking us for the opposite of what we just did. So they want to know, they're giving us the output, which is y, or which are our y coordinates, and we need to find the x coordinates that go with that. So if you're looking at a graph, depending on the graph, you might be able to tell. So with this graph, when I go to y equals 0 on my graph, that's going to be here and here, because I'm at y equals 0. I'm not moving up or down at all. The problem is those aren't falling on nice, neat crosshairs. I can't tell exactly what that is. All I can say right now is it's between 1 and 2. So what I'm going to have to do is solve. Or I wouldn't say solve. I would say let's look at the graph a little bit closer. If you use your graphing calculator, you can pull up the table feature, and you can see when y equals 0, the x that corresponds with it. You could use the trace function, and you can move around your graph to see what's happening there. And if you're not sure how to how to access the table or how to use the trace function, I've got help videos in the module about graphing calculators, so you can use those. I'm going to switch over to my online graphing calculator that I like to use, and I can use kind of like a trace feature. In order to use my graphing calculator or my online graphing calculator, I have to be able to put in an equation. So I see that it's a U shape, so that tells me it's x squared, okay, but my graph is shifted down 2, so that means I've got to throw in a minus 2. Now my graph matches my given graph, and now I can look and see what those values are. And when I just hover over, it's already got those flooded in for me, so I can see it's negative 1.4 is the x, and a positive 1.4 is the x. So again, if you are using your graphing calculator, use the trace feature or use your table feature, and look for when y is 0 and look for the corresponding x values. Or the other thing that we could do is we could, since we kind of generated that function or that equation, I could solve. So we said that it was similar to, ooh, I don't want that in red. Let's do that in black. Y equals x squared minus 2. So we know that that's where we're starting because it is a parabola, which is an x squared, and it's shifted down 2, so minus 2. So when we need to find x values that go along with a 0 output value, that is the same thing as saying 0 equals x squared minus 2. And now you can solve that equation for x. So you could use your graphing utility for that, or you can identify your function from the very beginning and then solve. And since we're having to take a square root, that's going to generate our two answers, which we know that we're going to get. And we got the positive and the negative of 1.4. So those are our input values for that. So you can't tell from the graph, so you either have to graph it or you have to come up with that function and solve. Either way will work.